Hello students, this is Dr. P. Shekar, Assistant Professor in Department of Mathematics in VIGNANA JYOTHI, Institute of Engineering and Technology. So today's topic is basic integration. One of the part in calculus, one is differentiation, the other one is integration. So both of these two, differentiation and integration concepts, are very much useful in a paper called Ordinary Differential Equations and Vector Calculus. So what is integration? Integration is to compute area which is bounded by some curve, namely some f of x. Suppose if we have an integral which is integral over a to b f of x dx, this computes area bounded by area bounded by the curve f of x between the limits x is equal to a and x is equal to b and bounded by x-axis. So in order to compute the area, what we're going to do is, it is to consider rectangular regions, rectangular areas under this curve. As we are finding a gap between at these rectangular areas, this is called as underestimation of the area under the graph of this function f of x. This also can be seen by overestimation, where we can consider the rectangular areas something like this, where we can see each rectangular area exceeding the curve f of x. So in both the cases we find some error. So that is why we put constant all the time when we integrate any function f of x. We have two types of integrals. One is indefinite integral, where the integration is free from the limits. We won't have the limits as lower limit and upper limit. For that reason, we put some arbitrary constant there in it. So how it can be defined? Suppose capital F be any function such that derivative of it is equal to some other function, and let it be named as some f, with c being arbitrary constant, then f plus c is said to be indefinite integral. So whatever we have on the right hand side, integration of f of x is equal to capital F of x plus c. This is called as integral to this function. So due to some error, we add some arbitrary constant to it. And another form of integral is definite integral. So definite integral because of the limits. Definite integral because of the limits. So it is integral over a to b f of x dx. So as we see the boundaries corresponding to x as some a and x as some b, it is calculated as some capital F of b minus capital F of a. So one with limits, it is called as definite integral. The one without limits is called indefinite integral. In indefinite integral case, we put arbitrary constant there in it. Now let us understand, let us recollect some common integration formulae which are useful in integration of some complex functions. So here I just list out some basic functions for which we can recollect the integration. So if at all f of x is given to be some constant, integration of constant is kx plus c. K being a constant integration is kx plus c. When it is integral power x power n, then integration of x is x to the power n plus 1 divided by n plus 1. So as we see n plus 1 in the denominator, so we must have the denominator is not equal to 0. That is possible only when n is not equal to minus 1. Likewise, we have an inverse function like 1 by x. Integration of 1 by x is given to be log x plus c. So here all these are examples for indefinite integral. So that is why everywhere you could see arbitrary function. So as for exponential function, integration of e power ax is e power ax divided by a. There is no common confusion among the students in differentiation and integration, especially with these functions like e power ax, sin ax, cos ax, something like that. When it is differentiation, a comes as a multiple, and when it is integration, a comes as a quotient. So here integration of e power ax as e power ax divided by a. When it is differentiation, it comes as a into e power ax. Likewise for sin ax, integration of sin ax is minus 1 by a into cos ax. Integration of sin is minus cos. Integration of sin is minus cos. As we are integrating, it is 1 by a. Likewise, integration of cos ax is 1 by a into sin ax, and arbitrary constant it is to be added as usual, as we are writing indefinite integral for all these functions. Likewise, for any other function, tan x, secant ax, cosecant ax, secant ax also we can have. One of the popular result that we're gonna use in integration is when we have two functions to integrate, then what is the integration of sum of those two functions? So this as integral over a to b f plus g, or you may write it as f of x plus g of x, as integration of f of x plus integration of g of x. So this can be integrated separately between the same limits, and we can sum up. Same lines, even if it is difference between these two, it can be seen in the same lines. Integration of f of x minus g of x, right? Let us illustrate this with one example. So we have integral over minus 1 to plus 1 x power 4 plus e power minus x. So this we can write it as integral over minus 1 to plus 1 x to the power 4 dx plus integration of minus 1 to plus 1 e power minus x dx. So first one is in the form of x to the power n. X to the power integration is x to the power n plus 1 divided by n plus 1. So we have 4 in place of n. So it is x to the power 4 plus 1 divided by 4 plus 1. And the limits corresponding to it are minus 1 to plus 1. And the second term, integration of e power minus x is e power minus x divided by minus a. So here in this place of k, we have minus 1. Limits are same, minus 1 to plus 1. So let me substitute the limits for both the cases. So in the first we have 1 by 5 as constant common. So it is x to the power 5. So it is 1 power 5 minus lower limit for x is minus 1. So minus 1 to the power 5 plus we have minus 1 here. So let me take minus common, and e to the power x is 1. So e to the power minus x is e power minus 1 minus x is equal to minus 1. So it is e power minus of minus plus 1. So this is equal to 1 by 5. What is 1 to the power 5? It is 1. Minus 1 to the power 5 also minus 1. So 1 minus of minus plus 1. So 1 plus 1 becomes 2. And here it has as it is minus e power minus 1 minus e. So this is how we can apply the sum rule in integration. Just similar to the case of differentiation, it is to differentiate separately, then sum up. Here we integrate separately and we are adding. Let us illustrate the same with another example. We have a function we have the integrand in the form of 1 by x plus cos of minus 3x. So what is integration of 1 by x? Integration of 1 by x is log cos x. Integration of 1 by x is log cos x plus integration of cos of minus 3x. Cos of minus 3x is same as cos 3x. Cos being even function, cos of minus 3x is cos function. So it is integration of cos. Integration of cos is sine. So it is sine 3x divided by 3. Here constant k being 3. Now it is to add arbitrary constant plus c. Why? Because we do not have limits for this integral. It is considered to be indefinite integral. So for that reason, we add plus c to it. One another rule, when we have a constant in the integral, when the constant is multiplied to f of x, then we can separate the constant outside of the integration. So it has integral over a to b k into f of x is equal to k into integral over a to b f of x dx. K being a constant, we took it outside. So all these are possible only when the integral is exist. Like in the previous case, some rule, f of x and g of x integral must exist. Even here also, f of x must be integrable. Then only we can think about this property. Same lines, one another example where the function or the integrand we call, the integrand is 3 into root x plus 1 by root x. So as you know, root x can be written as x to the power 1 by 2 plus 1 by root x as x to the power minus 1 by 2. Root x as x to the power 1 by 2, 1 by root x as x to the power minus 1 by 2. First we put both of these two in the form of x to the power n. In the first case, n is equal to 1 by 2. In the second case, n is equal to minus 1 by 2. I mean, in the first term, n is equal to 1 by 2. In the second term, n is equal to minus 1 by 2. So this comes out to be 3 into x to the power, what is that formula? 1 by 2 plus 1. X to the power n integration is x to the power n plus 1 divided by n plus 1. N being 1 by 2, so it is 1 by 2 plus 1. So as for minus 1 by 2. So x to the power minus 1 by 2 integration is x to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. So what is it? It is 3 into x to the power 1 by 2 plus 1 is 3 by 2 divided by the same 3 by 2 or n plus, now it is minus 1 by 2 plus 1. Minus 1 by 2 plus 1 is 1 by 2. So it is x to the power 1 by 2 divided by the same 1 minus 1 by 2, nothing but 1 by 2. Or the same you can write it as 2 times of, because here and here 3 cancel and this 3 by 2 comes out to be 2 by 3. So it is 2 by 3 into 3 into x to the power 3 by 2. X to the power 3 by 2. And here 1 by 1 by 2 comes out to be 2 into x to the power 1 by 2. So 3 gets cancelled. So this we can write it as 2 times of, because 2 is common for both, x to the power 3 by 2 plus x to the power 1 by 2. So this is what the integral of this. As we see, it is without limits. It is considered to be indefinite integral. So what is there at the end? It is to add the arbitrary constant c. So what we have used? We have used integration of x to the power n formula. What is integration of x to the power n formula? Integration of x to the power n as x to the power n plus 1 divided by n plus 1. N being 1 by 2 in the first term, minus 1 by 2 in the second term. One another example. The function or the integrand is 1 minus x into root x. 1 minus x into root x. So this we can write it as, upon multiplying 1 into root x minus x into root x. x into root x. So once again, how to write root x? Root x as x to the power 1 by 2 minus, what is x into root x? X into x power 1 by 2. So it becomes x to the power 1 plus 1 by 2. 1 plus 1 by 2 is 3 by 2. X into root x as x into x to the power 1 by 2. 1 by 2 plus 1 is 3 by 2. Now just as in this example, we have n as 1 by 2 in the first term, 3 by 2 in the next term. So formula is same. What is that? X to the power n plus 1. So what is 1 by 2 plus 1? 3 by 2 divided by 3 by 2 minus x to the power 3 by 2 plus 1. What is 3 by 2 plus 1? 5 by 2. So x to the power 5 by 2 divided by 5 by 2. Or you may write this as 2 by 3 into x to the power 3 by 2 minus 2 by 5 into x to the power 5 by 2. So we have used the same formula, integration of x to the power n. Here n being 1 by 2 and here n being 3 by 2. Okay, let us illustrate with this one more example. Now what do I have as f of x? F of x as 2 divided by 1 plus cos 2x. We do not have any direct formula to this. So what do? We try to rewrite this by using trigonometric formula. So what is the trigonometric formula? 1 plus cos 2x. 1 plus cos 2x. 1 plus cos 2x as 2 cos square x. 1 plus cos 2x formula 2 cos square x. So that is why in engineering mathematics, 3 are very important formulae. 1 is differentiation, 2 is integration, 3 is trigonometric formula. 3 is trigonometric formula. Without knowing trigonometric formula, sometimes it is very difficult to differentiate and integrate it. So here we have used one of the trigonometric formulae, which is 1 plus 2x as 2 cos square x. Similarly, we're going to have 1 minus cos 2x, which we could write it as 2 sin square x. So now let us replace 1 plus cos 2x by 2 cos square x. So it is 2 divided by cos square x. 2 divided by 2 cos square x. 2 gets cancelled and 1 by cos square we can write it as secant square x. 1 by cos square x as secant square x. Now it is integration of secant square. What is integration of secant square? It is tan x. Integration of secant square is tan x. So in order to get the integration of this 2 divided by 1 plus cos 2x, we make use of trigonometric formula. The formula here we have used is 1 plus cos 2x as 2 cos square x. And substituting and rewriting, we get secant square x and integration of secant square x as tan x. One more of this kind in trigonometric formula. So previously we have used x power n integration. Now it is integration of trigonometric functions. So now what do we have? It is 2 minus 3 sin x divided by cos square x. 2 minus 3 sin x divided by cos square x. So how could we write this? We can split this into 2 by writing 2 divided by cos square x minus 3 into sin x divided by cos square x. So it is integration of 2 into integration of cos square x. Integration of cos square x as secant square x minus 3 into sin x divided by cos square x. So we can write it as sin x by cos x, sin x by cos x, and 1 divided by cos x dx. So it is to integrate separately this 2 into secant square x minus 3 constant you can write separately, 1 by cos x as secant x, sin by cos x as tan x. 1 by cos x as secant x, sin x by cos x as tan x. What is integration of secant square? Integration of secant square is tan x. Integration of secant square is tan x. Same lines, we have to integrate secant x tan x. Integration of secant tan x is secant x. Plus, it is supposed to add arbitrary constant c. So now we have seen two examples where it involves, the integrand involves trigonometric functions. So in order to get the integration of such problems, we must be familiar with trigonometric formula. One another where we have the integrand as sin square x minus cos square x divided by sin x into cos x. So what can be done with this? Simply it is to split into terms as in the previous two examples. So sin square x divided by sin x into cos x minus integration of cos square x divided by sin x into cos x. So what we are doing? We are splitting the terms into two and integrating separately. So as we see, sin x is common for both numerator and denominator, which can be cancelled. So after cancelling the common term, it is sin x divided by cos x dx. It is okay to write dx. And here what is going to be cancelled? Cos x. So it is cos x over sin x. Cos x over sin x. Now what is the integration of sin x by cos x, or what is the integration of sin by cos? Sin by cos is tan x. Sin by cos is tan x and cos by sin is cot x. What is the integration of tan x? Integration of tan x is log mod secant x minus integration of cot x is log mod cosecant x plus some arbitrary constant. Integration of cot x is minus log mod cosecant x. As we already have minus, so this will become plus. Likewise, one more example in these same lines. So once again it is to split into two terms as sin square x divided by sin square x into cos square x minus cos square x divided by sin square x into cos square x. So once again it is the same thing. It is applying sum rule and then integrating separately. Whatever the common term is there for both denominator and numerator can be cancelled. Now what is the common term for both? Sin square is common, and in the second we find cos square as common. So it is 1 by sin square in the second term. 1 by cos square being secant square, it is integration of secant square minus 1 by sin square being cosecant square, it is integration of cosecant square. So now what is the integration of secant square? Integration of secant square is tan x and integration of cosecant square is cot x. In fact, minus cot x, it becomes minus into minus plus cot x. Again, it is the same indefinite integral we are considering. So plus c is to add arbitrary constant, it is to add. Okay, so throughout we applied sum rule in order to get the integration of f of x plus g of x form. So these are some problems for exercise. You may apply the same sum rule by integrating term by term. Okay, so this is it for today's lecture, today's class on basic integration. Right? Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.